Stars are hot bodies of glowing gas that start their life in nebulae. They vary in size, mass, temperature, and diameters, ranging from 450 times smaller than our Sun to over 1,000 times larger than that of the Sun. The color of a star is determined by its temperature. The hottest stars are blue and the coolest stars are red. Our Sun has a surface temperature of about 5,500 degrees, and its color appears yellow. As the gases start to begin to coalesce and start forming, they form protostars that have enough matter that the central temperature inside reaches over 15 million degrees. At this point, we've hit stage 2 of the star formation. At stage 3, the temperature rises even higher and nuclear reactions begin in which hydrogen fuses to form helium. This is the beginning of a real star. Stage 4, we have energy being released, and the star begins to fight itself. As it's compressing in by gravity, it's forcing itself out as it's releasing energy, and now it becomes a main sequence star. These are the kind of stars like the one in our solar system. A star of one solar mass remains in the main sequence for about 10 billion years. That's its typical life. That's stage 5. At the end of that 10 billion years, we start stage 6, and that's where the star runs out of fuel and stops making helium, and it starts to contract, and it creates a shell around the core. In stage 7, the core becomes hot enough for the helium to fuse to form carbon. So it's still changing. It's still
way out there in space, there's huge clouds of dust and gas, and if one of those clouds of dust and gas is massive enough, its own gravity causes it to start to collapse. So it falls in on itself, and towards the center of that cloud, it gets denser and denser, it gets hotter and hotter, and eventually the particles that the gas and the dust are made of are brought so close together that they start to stick together, they start to fuse. That's the energy source of a star. The star switches on and begins to shine.
Inside every newborn star, hydrogen atoms are fused together to make helium. This process is called fusion, and it creates the energy that powers every star. What happens to a star during the rest of its life depends on how massive it is at its birth.
A star like the Sun is in a delicate balance between gravity, which wants to make the star collapse in on itself, and the pressure that pushes outwards that comes from the energy that's been produced in these fusion reactions happening at its core. However, at some point in the future, the hydrogen runs out, and at that point, the core of the star will start to collapse in on itself under its own weight. It gets denser, it gets hotter, until a point where you can actually start to use the helium atoms themselves as the fuel for the fusion, pushing helium atoms together and making carbon and oxygen the next heavier elements in the periodic table.
As the star begins to fuse helium, it creates more energy, and that causes the outer layers of the star to expand. One day, our Sun will grow so large it will swallow up the inner planets of the solar system, out as far as the Earth. It will become a red giant. For the Sun, this will be the beginning of the end.
What happens is, as the outer layers of the star get farther and farther from the middle, the force of gravity that they feel is getting weaker and weaker. And actually, the star loses hold of its outer atmosphere. Its outer atmosphere drifts off out into space. It expands out to become a planetary nebula. And they're some of the most beautiful objects in the universe.
Once the outer layers have drifted away, all that is left of the star is its core.
A white dwarf star is the dead remnant core of a star like the Sun at the end of its life. What's left behind is something that might weigh as much as half the mass of the Sun, but it's only about the size of the Earth. So it's an incredibly dense object, it's dead, there's no nuclear fusion going on it anymore, it's incredibly hot, but then over millions of years it will gradually cool down to become a black dwarf.